Maganda umaga sa anyang lahat. Good morning to everyone out there. In today's Terminal Linux video, we will be discussing permissions and ownership of files and folders, and since this is Terminal Linux, we will of course be using the terminal. Specifically, I will be working with the console terminal. This is a terminal emulator that comes with the default KDE Plasma desktop, and it's running on Arch Linux. I think I said this before, but just to point it out, there might be some differences. However, this should be pretty much irrelevant, as what is presented here should work on any Linux system using any terminal running any bash shell. And I do highlight that one, bash shell. I talked about shells, I believe, in another video. I'll have to check that out and link it, but I think I did talk about the different types of shells. Anyway, as normal for this series of videos, I'm going to do my very, very best to keep things at a novice level for new users and not to go too far into the weeds or down any rabbit holes. And there are a few rabbit holes here, but I'm going to try and avoid them. Not quite sure how entirely successful I'm going to be, or have been at some times. Anyway, onward. Generally speaking, the desktop Linux is often a single user. That is to say, you're the only user on your system. Back in the day when we were lucky to have a computer per household, multiple people used the same computer, and Linux was designed around a multiple user system, which is something to keep in mind when we start talking about permissions and ownership. Today, however, most households that have a computer have more than one. In point of fact, most people have their own, be it a desktop, laptop, tablet, or even phone. And chances are good, if you have a computer, you are probably the only one using it at this day and age. I bring this up again, as I said, Linux was designed to be used in a multi-user environment, and that's carried through to today. Ownerships and permissions have been around for a long time, and this is apparent from how they are implemented on the file system. When talking about files and folder permissions and ownership, keep this in the back of your mind. It might help you understand why some of the things are the way they are. Now, there are two sections to this video. The first, obviously, is an explanation of the Linux file and folder permission system. If you know this already, feel free to skip ahead. The second part is going to be well, let's just call it an example. Some might call it fanciful. I call it entirely possible, having worked in the corporate environment, but neither here nor there. It will be an example of why file permissions and ownership are important. A quick note, we will be working within a home folder. That's my home folder. Anyways, I bring this up because in theory, I should own everything in my own home folder and administrative privileges should not be required. Oh, there's at least one instance I can think of where I'm going to need to use sudo or su. But for the most part, administrative permissions aren't going to be required. I think when I create a group, I'm going to need to use sudo because that's a root file. We'll cross that bridge when we get to it. And anyway, sudo or su, I'm going to hope you already know because that's going to be a little deep, but that's going to be the subject of another video, not this one. But basically, sudo and su are ways of granting yourself administrative permissions on your computer. So yeah, I can think right now, I'm thinking there's one instance, maybe two instances where I'm going to need to use sudo. We'll see when we get there. So getting right into it. First subject, file, folder, permissions, and ownership. So basically, everything in Linux is a file or a folder. That's not exactly true, but it's a good concept. Files and folders have permissions. There's 3 permissions you can have. You can have 1, 2, or 3, not just one, but there's 3 permissions: read, write, and execute. Things like deleting files are covered by write. Files and folders also have ownership. And there are 3 ownership groups. Users are the actual owner of the file, and we'll see that term used a little interchangeably, users and owner. And then there's the group, and then there's the other. A group is someone that you decide upon, while other is everybody else who has access to your computer. We'll go into that a little more too. These determine who can access a file or folder and what can be done with that file or folder. Multiple ways of representing permissions are Related to ownership is also available. There is a symbolic method using letters, and then there is the numeric method. We'll cover both of them. Some of the commands we're going to be using, we've used before. ls, which is list, which allows you to list the contents of a folder. chown we haven't used, or change owner, and chmod or change mod. We haven't used those yet, but we will be using those to change ownership and change permissions that each file or folder might have. Group add and group delete for managing our groups, and I've talked about that in previous videos, but we'll go into it a little bit here. CD or change directory we're going to use, of course. Touch was designed to mainly update timestamps. However, when you issue the touch without a file name or with a file name, when you issue the touch command with a file name, it actually creates that file if it doesn't exist. Cat for catalog, that allows us to look inside a file. VI is a text editor. You can use Nano or Vim or whatever you like. There were a few commands when I started this that I didn't think of, but we will be using. grep is a tool for searching for patterns or specific keywords within lines. Clear basically clears the screen. Stat is going to give us another way of looking at file permissions and ownership other than ls. pwd, present working directory we've used before. Makedir to create a directory, and rm to remove files and directories. And there's probably a few I forgot in there, but we will get to those as we get along, okay? Okay, let's talk ownership and permissions of files. And this is going to go hand in hand with my little example I've got going later on. Let's say you, in your own home folder, have a project you're working on. We'll call it secret project, and you don't want others snooping in it. To go along with the actual permissions we're talking about, we're going to assume you have some sort of executable file you've created. We're calling it test.sh. Test.sh would be the extension for an executable script file. Just go with me on this, okay? So you're the user owner. These are in your home folder. So you have all permissions. You can read these files, which means you can open them up and look at what's inside of them. You can write these files, and writing means you can change them, which includes deleting, modifying, copying, all that stuff is covered by write. And because you have an executable, you can execute the files. So you're the owner. We're going to try and refer to this as user because that's what the commands use, not owner, but you are the owner, and owner is equivalent to user. So we're assuming you're working in some sort of business corporate environment, and you've been working on a project, and it's caught the attention of your mid-level manager, who's brought up to you a higher level manager, and they think you need a team to work on the project with you. However, you think the people in the team are basically stooges for the mid-level manager. We'll call them brown nosers. But you've got a team, and this team is going to be your group, and you need to give them permission. For this exercise, you need to give them permission to be able to read what you've created. You need to give them permission to execute what you've created. However, since we'll assume your folder is the only official folder, you don't want them writing to your folder, therefore they can't take credit for your work. So what's our permission structure? Well, for our group permissions, they need read, and they need execute. They have no need to write. They can look at your code, execute it, make suggestions, and you can make the changes because they cannot change your files. Your project's going along well. You're keeping the group at bay, and then one of your upper level managers decides that since this project's going so good, we should let other people in on it. So they say, you need to let in marketing, you need to let in quality, manufacturing, R&D, a whole bunch of other people from other services or other divisions in your company. And well, that's going to be a big pain in the ass to create a group file. And these people really, they don't need to be able to read your code. You don't want them reading your code because, like, for example, quality will make all sorts of weird comments that have nothing to do with the quality of the code. Same with marketing. They just need to be able to execute it. And like I say, this is a lot of people, so we're going to use the other category, which is our final category. Instead of adding them to a group, we're going to give others on the system execute only permissions. So they can't see anything, they can just execute them. So they can just run the command. They can't see it. They can't change it. They can just run it. Now you may ask how we do all these things. Before we jump into that, let's go over the two different ways things are represented. So read is your 4-point command, write is your 2-point command, and execute your 1-point command. So to give yourself read, write, and execute, you either do the RWX or you can do the 4 + 2 + 1 = 7. Remember, we have users, groups, and other. And for example, the group, they have 4 because they can read, they have 0 because they can't write, they have 1 because they can execute. So it's read, nothing, execute, and 4 + 1 = 5. Well, 4 + 0 + 1 = 5. And if we go down to others, they can just execute, and it's 0 + 0 + 1 = 1. So 0 in the read permission, 0 in the write permission, and just 1 in the execute. Some people are more comfortable with the symbolic letter representation. Other people are more comfortable with the numeric representation. That's something you're going to have to figure out for yourself as you work through this. All right, let's go ahead and jump over to the console here. Let me increase the font size so we can actually read this. And as you can see with the pwd command or present working directory, I am in my home folder. Again, we've said this before, but the tilde sign in the header of your command line represents your home folder. So let's do an ls, our list command, and we use the tac L option to make it a list because we just used ls and print out a bunch of stuff. ls-l will format this into a list and give us a lot more information. So this is the basic output of ls-l, and we're going to go through this. Let's use the documents line, and we're going to go through this one piece at a time. So way off to the left, we have an L. That is the stands for link, and we'll see that in the document name that this is a linked file. It could also be a D for directory or a dash for just a regular file. Then we have a group of 9 permissions. You saw these before, RW and X. The first RW and X is the user or owner's permission. I should mention here, links don't really have permissions, so they're RWX across everything. It's the end file they point to that has permissions. Anyway, the first RWX is read, write, and execute for the user. That's you. The second RWX is read, write, and execute for the group. And the final RWX is read, write, and execute for the other group, everybody else who's using the computer. The one next to that is your hard links. We're going to skip over that. That's one of those rabbit hole things. But after that, we have, well, in this case, we have RT, which is my username, and every user has a group. So it's username RT, group RT. Like I say, when you create an account, you usually get a group along with your username. At least that's how most distros are set up currently. Then beyond that, we have the size of a file. This is a link, so it's pretty small. It's just a pointer. Then we have the modify date. This is the modify date, and we'll be talking about that a little more later. And finally, at the end, we have the file name. In this case, it says documents, and we've got the little arrow and the folder it is actually pointing to. Now, if we run the stat command for our documents folder, we're going to get similar information, but we're going to get additional information. For example, well, first off, we have the file. We see it's a link. You can see I want to go down to the 4th line here, where you see the access 0777, those 3 sevens. I don't want to talk about the 0. That's another rabbit hole we'll get to in a later video, but we have the 3 sevens, which is our number representation. Remember, read 4, write 2, execute 1. So it's 7 for users, 7 for group, 7 for owner, and then you can see our actual permission line here. You can see your UID and GID, which is user ID and group ID. If these are 1,000 and above, these are regular users. If they're below 1,000, they're probably system users. And then we have a lot more different times displayed here. In addition to modify, we have access, change, and birth, which is the creation of the file. So as you can see, you get a lot more information off the stat command, but you can only do it one file at a time. Okay, this section might seem a little complicated, but I got to talk about users and groups. So first thing we want to do is to do ls tac L, but we're going to add the directories etc, and then we're going to grep for a file that starts with passwd. And there's 2 of them. We're interested in the top file here. And you'll notice permissions here, read or write for the owner, user, read for everybody else, groups and other. And we notice also that the owner is root and the group is root. That's your administrative account. Anyways, we can read this. So we'll do a cat and we can search through here and find our user account, have our user ID, our home folder, and our shell. Now let's look for a group in the same directory, and we want the top entry here. And this is a little tough because there's a lot of entries in this file. So what we're going to do is we're going to grep for RT, and there's some interesting things I want to point out here. You can see the RT group, third line, RT kit is, well, that's just a coincidence. But if you look at the first line, you have power. People in this group, the shutdown command, the reboot command, all have power as a group. And if you're part of that group, you can run these commands, hopefully without administrative permissions. At the bottom, we have VBox, that's VirtualBox users group, meaning you can use VirtualBox without administrative permissions. And then wheel, this is our sudo group on Debian-based distributions. This will probably be called sudo and not wheel, but it's called wheel on Arch-based distributions. This is what puts you, if you're in this group, you can run sudo and execute commands with administrative privileges. Okay, before we get too much further along, let's jump back over to the GUI and we'll open the Dolphin File Explorer, again, another KDE program. And we'll go ahead and take a look at our documents file here and see what it looks like in the GUI so you can have a comparison. I mean, it's nice to look at things in the terminal, but it's always so good if you can compare it to what's actually in the GUI. And you can see here, we can see our link, our document name, and you notice you've got created, modified access dates here also. Your permissions, this is link. Like I say, links don't actually have permissions, so they're all RWX. It's the file they point to. Then you can see the owner and the group, and then some details. If we jump in here and look at, say, another file, it's a little different. You got the file name, the size, the location, and here you can actually see the permissions. And interestingly, in this GUI using Dolphin, you have one executable box, which makes everybody's permission, gives everybody the executable permission. You also have advanced permissions where you can actually set this stuff individually rather than through the all-in-one for the execute. You also have set UID, set GUID, and sticky bits. Again, another rabbit hole. We're not going down in this video, but it's there. Also got some built-in functionality for validating the file with checksums. If you use that, you can actually do that in the command line too, but again, not going to cover it in this video. And some general information. So just wanted a comparison here between what you're seeing in the terminal and what you're seeing in the GUI. It's basically the same information, okay? Okay, let's jump back over to the terminal. Let's look at a few other files in different locations. First one we'll look at is variable log. And if you ever have problems when you go online, people are going to want to know what the logs say. This is where you find them. You notice they mostly belong to root. There's a couple that don't, but they've also got read write and then write for everybody else. There's some drawers, but you can see there's a variation of permissions and owners and groups here. And again, you can use the stat command for additional information. Let's go jump over to user bin. These are binary files. And again, here you can see some are not owned by root. Well, they're owned by root, but they're not part of the root group, like the TTY file. Again, different permissions, but since these are all binaries, they should all have execute permissions since everybody needs to run these. And again, the stat command can give you a bit more information on the files. Now, before jumping into our example, we want to take a look at the chmod or chmod man page. We're not going to go through this in any detail, but it's there if you got man pages installed and you want to read about the command. You have all the options and various other items. Same with the change group. You can look at what's in the command. Like I say, we're going to go through them. We're not going to cover them in detail, just how we use them for this instance. But if you want to find out more, this is where you look. Enough procrastinating. Let's get into our example here in the terminal. So we're going to assume you you're creating a project. We call it a secret project. And if you look at it, there's defaults used by something called umask that'll give you default permissions when you create a file. And you can see here for secret projects, we've got read, write, and execute as the owner, but read, execute as basically groups and everybody else. So we're going to use the chmod -R for recursive. One thing to note here, if you look at previous videos where we used like move or remove or commands like that, we use a small r. Both chmod and chgroup use the capital R for recursive. And then we're saying group and others equal nothing, basically. And then we give our folder name. We could also use 700, which is, for us, it's read, write, and execute. For everybody else, it's nothing. And now if we do a ls-tacl, we can see that's what permissions we have. So let's change into secret project folder. We'll do an ls. There's nothing here, but we're going to do a touch command and we're going to create our test.sh file. And now it's here, but it's got read, write, 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 read, write for us, write for group, write for everybody else. Oh, excuse me. It's got read, write permissions for us. It's got read permissions for group and read permissions for everybody else. So we're going to do a 700. And again, that basically removes everybody else's permissions, both group and other. Now let's go ahead and create a quick executable file. Since we want this to be executed, we'll just throw in a bunch of bash echo commands, nothing fancy. Yeah, I need to put a shebang at the top of this. I'll link another thing I've got on doing another video I've got on doing a bash script for a specific purpose that talks about things like that. But anyway, now we need to change, if we need to change our, let's do a cat, see what's inside this file. Okay. And now let's execute our file. And it ran. And if you look and you're wondering, so again, we'll use the stat command. We've got read permissions, write permissions, and execute permissions for this file, so we can run it. Nobody else can do anything with it but us. Let's take a look at our group command. Since we're going to have to add this group, that was part of our example, is that we got assigned a group by our mid-level manager. So if we look in this file, we're going to use sudo group add. Remember, I said we got to use sudo because group, if you look at the file, is owned by root and we've only got read permissions. And we're going to group add the brown nosers. And if we do a grep, there it is, brown nose, and they're at 1001, so they're a user group. Now we can just add all the people we need to add to the brown noser group. So user mod, again, this was the other example. I wasn't sure, but yeah, I think I need to use sudo for user mod because I'm modifying a particular administratively owned file. Add group, brown nose, I added myself to the group. And now you can see if we look inside the group file, I've been appended. You basically just go through like this and append everybody who needs to be appended. I mean, technically I didn't need to append myself as I've already got read, write, execute permissions, but single user here, so I don't have any other accounts. I didn't want to create an additional account. So now we're going to change owner, tac R, capital R in this case, remember. And usually the way this command works is you've got a user : group. We're just saying : group name, the brown nose, and the project file, and that will add that group as the group for the project. And guess what? I need sudo on this one too. Okay. Now if we do an ls, we can see that our project folder now has the brown nose added as the group. So far so good, but they have no permission, so they still can't do anything. So we need to do chmod, and again, using the symbolic letter representation, group plus R and X. So it's going to take the group entry and add read and execute permissions. And you can see it's done. We could have used the numbers too. which would have been 750. And that's how you add users to a group and then modify the group on our folder. And basically that gives them access to read and execute access to things in the folder. We haven't given them write access though. All right, now for the second part of our project is we need to add other group. We don't want to add a huge number of people to different groups. We just want to add them all blanket. So we're going to use the other permissions, which is anybody else on the computer not specified by the group or by the user. So we're going to use the numbers in this case, chmod 751. Remember, 1 is execute, and that's all we want to give to the others. If you go back earlier in the video, we talked about that. And now we can see that others have an execute permission. So they can execute the file. It's interesting, they don't need execute permissions to the folder. They should now have access. And we can see here, we basically changed it not to the folder level, not the secret project folder, but we changed and gave the test.sh file executable for everybody. You don't need to give it permission to the folder because they're supposed to type the full path, and the full path will take them to the file, and they will use the file permissions and not the folder permissions. We could have also used the O plus X for the symbolic representation. And that's basically it for our project example. Okay, that was fun. I hope we didn't go down any rabbit holes, or at least not too deeply. I mean, we got into a little bit of stuff with the adding groups and things, which is probably more than a lot of people want to do, but I'm hoping you got a good understanding of the file permissions and of the group and of the ownership of Linux files, be it user/owner. Yeah, I always want to call it owner. That seems more real to me, but it's user and then group and others. Again, this example the example we use here might be a bit far-fetched, as generally speaking, most corporate environments don't use Linux, and you're not going to be doing it on your personal computer. But the point is for you to understand how Linux file permissions and ownership work, and I'm hoping you got that out of this. As always, please, if you watch this video through to this point, please like, comment, and subscribe. And we'll see you next time around, okay?